Good morning. I don't know if that made anybody dizzy. Oh my goodness. That made me dizzy just watching myself. Welcome back. This is our second week of live streaming Algebra 2 notes. If you're watching this after the fact, welcome to join us Wednesdays at 11. I do advisory, I prep for this, and then I teach you. And then just to clarify, this is not this week's lesson, this is next week's lesson. So this week on Monday, we officially dropped 9.3 Part B, which was Trig in the unit circle. So I'm hoping you've maybe already done that by the time you get to here, but it's not as imperative as it was last week to have it done ahead of time. I lost a viewer already, what the heck? Good morning, Lauren. I started out with 3. It's fine, I don't care. I want to show you why this is so important, though, because I ended up in college, and they were like, do you know why Trig's important? And we were like, no, not really. And they were like, it's to model things that repeat themselves. And my mind was blown, and that was a college thing, and that should not have been a college thing. That's a high school level concept. So let me just monologue for a little bit here. In Algebra 1, we taught you straight lines. Those model certain things. Growth over time, like supply and demand, wolves and rabbits, all that kind of stuff. And then we taught you parabolas, which is gravity stuff coming down again. You are right now in the middle of seeing why exponential functions are so important, because they go like this, whoop, and then what you're seeing is like that kind of reflected and coming back down again, flattening the curve, etc. So that's all also equally important. I'm just going to pop this over a little bit. Boop. So those are things that model our world. Gravity, income, diseases. What do we do when things repeat themselves? Let me show you what I mean. This is my favorite video, and I'm so glad I'm starting with this. I don't know how this works because I have a YouTube video open on my screen. We're going to watch it. So this is the title of the YouTube video. It's Jamming from Inside a Guitar with Maple the Pup. And that's the YouTube link. So this is the official, I don't know how to quote a YouTube video, but we're going to do it anyway. So watch. This is my favorite part. I don't know if you can hear it or not. Let's see. I have to pause it a little bit better. Do you see that? Do you see this right here? That's a repeating function. Okay. I'm going to show you more. Let's just watch a little bit longer. Oh, do you see how all of them do that? So good. I'm going to go back to my face. And I'm going to close that one so that way it doesn't eat up my internet. But, okay, that was vital. Because in music, the strings do that. Sound does that as it approaches our ears. It does that wavy thing. Okay, let's look at another example. This is the eclipse and the moon, and I got it from NASA. So it's not just made up numbers for math. This is actual, but do you see the waves? Same waves. Different equations, but same waves. Let's look at, this is called the equation of time, and has something to do with how the Earth orbits and how the sun shifts, and all of that kind of stuff. Do you see there's 3 waves on here? Do you see them? Okay, so we have a lot in our world. There's more than just this. But we have a lot in our world that are sinusoidal functions. This is a sinusoidal function. That's a sinusoidal function. It's things that are wavy is a sinusoidal function. I'm going to write that in our notes in just a little bit, but I just want you to see it and hear it. Great. Now, why am I doing this right now? Here's our circle. okay? What it's doing is it's taking the x heights. Do you see that little red line? Nope, those are all the y heights. I'm so sorry. Those are all the y heights. The y heights is sine. Remember, sine is y over r is 1. This makes a wave. One time around the circle makes this specific wave. This is a sine function. And it looks an awful lot like these things. That's why they're called sinusoidal. And then the thing that breaks some brains is that, is that a cosine function? Where's my cosine function? Oh no. It's fine. I'll just fix it right now in the middle of the chat. Cosine. Here we go. Here's the cosine function. Still from purple math. But cosine does the x direction. See that purple line? So it's finding the distances, and cosine makes this graph. I would show you both. We're going to graph both in our notes, but I just want you to see it. So one time around makes this graph, top to top. That's why we care about these things. I need this other page open up here. Here we go. That's why we care. We care about trig because it models things in our world that make curves and repeat themselves. Because if I keep doing this and I stack it on top of each other, I end up with this like woo, just like this. And that. And the puppy in the guitar. Not the puppy in the guitar. The puppy behind the guitar, and we were inside of it. Music, time, planets, the moon, which isn't a planet, but it's kind of in the solar system still. Heat in our world. Everything kind of does this woo thing, and that's why we care. We are absolutely not going to get into that kind of detail where we're going to graph something like this. But I do want to break down the parts of a graph like this, because what we're going to do today is just identify the parts of a graph and equation, and then next week we're going to graph sine and cosine using that information. And I'm going to post some graphs, so if you want to print those off ahead of time, I'm going to post them in the information section on the Google Classroom. If you go over to classwork, there's a little section for information. I'm going to post some sine graphs because they look different. They look like this. They don't look like our normal square. So if you have a printer, you can do that. Okay. That was my exciting introduction of eight whole minutes of me telling you why these are important. Because nobody told me in high school. They just said, just graph it. They might have told me. I don't know. But I had kind of boring math teachers. Sorry. So I just wanted to show you why, because I wish that somebody had showed me why back in the day. Okay, let's make some definitions happen. Also, I am gonna heck and color code today. I have 4 colors. It's pink, purple, blue, and green. If you're a Monday watcher and you want to play along, blue and purple look kind of the same in this series, but it's gonna be fine. It looks different when I'm actually using it. Okay, so let's define sinusoidal, because I want you to have that. So a sinusoidal function is any function that repeats itself. Okay, sine and cosine goes around a circle. If I went around a box, it'd be a different shape, but it would still be a sinusoidal function, because the sinusoidal functions repeat themselves, like this one does. All right, we're back. Okay, so any function that repeats itself is a sinusoidal function. We're good. Let's just break down some sort of sinusoidal function, and I'll explain to you what the parts of it are. So let's say I have, now usually with trig graphs, there's my y-axis, and then I have some sort of line like this, where it's a little bit shorter on one side and a little bit longer on the other side, because we mostly care about the positive side, but the negative side's still there. Okay. And then let's just say that this is 1 on each thing. And let's just say that this is pi, 2 pi, 3 pi, 4 pi. I am making this up as I go along, and that is A-okay. But I should also do it on this side, negative pi. Okay, I'm just going to graph one of these sinusoidal functions because we want to talk about the parts of it without directly relating it to sine and cosine yet. That'll be down here more. So let's say I start up at 2, I come down to pi, I make like a little V shape here, but I'm not going to connect it like a V shape. What I'm going to do is I'm going to curve it because we like our trig graphs like we like our women. Nice and curvy. Okay, so if you're going to get a little better at this, and I'll show you some tricks along the way, but this is a sinusoidal function. It's going to repeat itself. This is kind of based on a cosine function, but I'll show you why I know that in a little bit. Right now it's just a sinusoidal function, which doesn't necessarily mean it's sine, but it is sinusoidal, which is different. But not really based on different things. Okay, let's talk about some vocab words with this. That's why I'm calling it the anatomy, because I want to show you some vocab words that are attached to these kinds of graphs. Okay, I don't know, let's just start with green. Let's talk about the midline. So the midline, you're not going to believe this, is literally the middle line. Line in the middle. In this case, specifically, it is the x-axis, but in general, it could be moved up or down just a little bit. And we're going to do that officially next week. This week, it's not going to try to trick you at all. The midline's going to be the x-axis, and it's going to go up and down from there. So that's the midline. Line in the middle. Makes sense so far. We're good. Here's what makes less sense. I'm switching to blue. What makes less sense is this thing called the amplitude. And that's not normally a word that we hear when we talk about, like it doesn't break down to like the attitude of the amp or something. That'd be cool. The amplitude is the height. Oop. From the midline specifically. It's not the total height, it's like half the height. So it's from midline to the top, or it can be from midline to the bottom. Both of those are the amplitude. In this case, my amplitude is 2. Because it's 4 total, right? So it's 2 above the midline and 2 below the midline. It's not going to be like 5, it's not going to be like 5 above and 3 below. That's just 4 and 4 because your midline moved up 1. I'm dropping people like flies. What's happening here, you guys? I think it's just you and me, Lauren. It's fine, I don't care. I do care a little bit. I was hoping this would be like a normal class, but whatever. 11's hard to deal with sometimes. Okay, now here's the really fun part, because it confuses a lot of people. Switching to purple. We're going to talk about the period length. All right. The period length is what happens when you have one complete cycle, which sounds like I'm talking about lady parts. Can you tell if that's purple? Yeah. Okay. It's so important that you can find the period length, because that is basically like a stretch this way, that I actually have quite a few problems tonight where you just identify the amplitude and the period length from the equation. And then I make you do it from from the graph. And then I make you do it from an equation, which I'm going to teach you how to do officially. So, period length is one complete cycle. So that's mountaintop to mountaintop or valley to valley. Okay, so I'm going mountaintop to mountaintop to be able to check because I only have one valley here. I don't have a valley over here or over here, even though I could probably find it pretty easily. I don't go middle to middle because people forget that this is only one little section. So it's got to go. Why not? I didn't grab, I didn't tell you to grab a highlighter, but I'm going to do it anyways. So my period length is top to top again. If I just do middle to middle, I only get the bottom section and I don't get a full full mountaintop as well. And I'm going to talk about this like this the whole time. Peaks and valleys, peaks and valleys. Whoever left came back. Welcome back. I'm just doing my notes real quick. So this one has a period length of 4 pi. That one has a period length of 4 pi because it takes 4 pi for it to get from top to top again. Okay, mountain to mountain is by 4 pi. It's how long it takes to do a complete cycle. I'm just going to flick my pen at you. Okay. We also can have like a shift left or right. I don't know why I have the pink one out because I want to be careful about something real quick, but I have it ready just in case I need it. So this is the anatomy. Amplitude, midline, and period. So you should hopefully be able to find the amplitude of a sinusoidal function and the period length of the sinusoidal function. And I'm just throwing in midline now because we're going to use it next week and you might as well get used to finding it, even though it's going to be that way. Uh-oh, Lauren got... It was Lauren that left. Who's the one? Is it just me watching myself? Lauren. Let me recap because it's because you were gone, but maybe somebody's confused anyway, so I'm going to go through it again. Okay. So we know the sinusoidal functions are the curves, right? We've been talking about that. That's just a sinusoidal function. So I just made one. I just made my little curve. And then it's going to buffer, so you're going to miss some stuff anyways. So my height is my amplitude. It's from the middle to the top or the middle to the bottom. So in this case, my amplitude is 2. It's my highest height is 2 up from the middle. The middle is called the midline. Maybe I'll highlight this green. I don't have... Y'all, I left my green highlighter at school. I'm kind of mad about it. So that's my midline, is literally the line in the middle. It's kind of like our axis of symmetry when we were in quadratics, but now it's this way, and it goes forever. And it's not symmetry, so we don't call it that. And then the period is either mountaintop to mountaintop or valley to valley. But I don't have 2 valleys on this graph, so I just did mountain to mountain. So that's how long it is. 1 cycle. I don't know if that helped you, but I did it anyways. Plus I'm gonna keep going because it's right now just on the highlighting stage. So I'm just gonna show you the sine and cosine functions. So this is the sine parent function. And we've talked about parent functions enough that you honestly probably could just do this by yourself once I show you the shape of it, but I don't want to do that. I don't want to send you on your way. Okay, I think you're getting caught up soon. Okay, so sine, I had to get rid of my animation, I think. Let me see if it's still here. That's sine, good. Okay, good. So sine starts in the middle of the graph. It starts right here. And then these are super weird numbers. Do you see the super weird numbers? But do you recognize one of them? This one is pi. Okay, and this is 2 of that. It's 2 pi. So sine starts at 0, goes up to half of pi, down to normal pi, at the bottom at 3 pi over 2, and then back to 0 again at 2 pi. We're going to do all of that on my graph. So 0, pi, 2 pi, and then we're going to go halfway is half of pi, which we write pi over 2. Remember my whole unit circle day where I showed you all the parts. And then this one's 3 pi over 2, because pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, but we simplify them. Oh, it's still playing on the thing, cool. And then it goes up to a height of 1, and the bottom is negative 1. So we go up to 1, down to pi, bottom at 3 pi over 2, and back again at 2 pi. And of course, I wrote on that, so I wish I had my white out here. And then we curve up, we go down, we curve down, we go back up. And it repeats itself. It redoes that as it goes. It's not just this little section. It does another one over here. It copies and pastes that period. It redoes it all the time. I always feel like I'm talking about lady time periods. It repeats itself. It happens every month. Every 28 days or so, depending on your specific life cycle. Okay. So this is a basic sine function. Let's just talk about those parts again. My midline is at 0, or is right here. I'm going to call it ML, midline. It's really small. Let me zoom in. It's really cool, you guys. Okay. My amplitude was blue. Is 1 on the basic parent function. And my period length, I thought I messed up for a second. So in this case, I can't really go mountain to mountain, right? And I can't really go valley to valley because they're not here. So I'm just going to be really brave, and I'm going to make sure I do the entire loop. Okay, so when does it restart? It goes here. That's when it starts restarting again, is at the end there. So my period is 2 pi. And then I just want to clarify once more. Sine starts at 0 and goes up. Maybe I'll do that in my pink color, because I want to remember that. Sine starts at 0 and goes up. Because that's just something to remember from when we are going to try to graph these in a little bit. Okay. Let's talk about the equation for a sine function. I want to show you where all these parts come from when we do this. So normally we have y equals, I'm going to leave a space with me. Something sine, something x, plus something. Leave the spaces. I'm doing it on purpose, I promise. Okay. We know the amplitude from the number in the very front of sine. If it's a 4, it's a 4. If it's 7, the amplitude's 7. If it's a -3, it would still look like this, but it would be flipped over, right? It would be going down, but it would still have the same amplitude, because amplitude is distance from the bottom to the top, or the middle to the top, or the middle to the bottom. That's amplitude. So amplitude's the same right here. It's still 1, middle to the bottom. Okay. Our midline comes from the plus. Sometimes we use M, sometimes we use C, sometimes we like the H and K. I'm just going to use a C. No, I'm going to do a K, because I want to do the HK like normal, shift up and down, right? This is the midline. Do I want to make lines all over the paper? Probably not. Am I going to do it anyways? Yeah, why not? But I'm color coding, so that way it makes more sense. Okay, now here's the one that's not easy. I have a b value. But it's not the period. It's not. What we do is we take the normal starting period of 2 pi and we divide it by b. Okay, so in this case, b is 1. b is not 2 pi. In this case, because my period is 2 pi, if I do 2 pi divided by 2 pi, I get 1. So this is not a direct correlation. The other two are easy. They're direct correlations. Nothing's different about them. B is different. So let me highlight this or something. I have my little jar of highlighters and I just want it to be, it's fine. So that one's the only one that's not a direct correlation that we actually have to do math. What? I know. My jar is like sweating on the... I need a big coaster. Okay, that was sine. Cosine's very much the same. Just slight modification. One slight modification. But if you can do this for sine, you can also do this for cosine. You understand enough, you're good. I'm also going to write down the cosine one, though, because I want you to know the parts. Okay, I'm going to move it over. You can't pause because it's live, but if you're home and I'm going too fast, you can pause. I guess there's pros and cons of both. Also, I'm just curious who my mystery watcher is. It might be one of those people that keep emailing me that, or YouTube messaging me that I'm doing a good job and aren't really in my class. Might be one of you who all have the same picture and are probably just spam accounts, but whatever. Okay, so here's this cosine parent functions. I'm going to leave the same space. And then again, I'm going to have these types of graphs to be able to print off if you want to do it on that, because that's something that I just have available at the end of the school year, usually is sine and cosine graphs, just so you can draw on there. But today I don't have that. All right, same thing. 1 and -1. Let me be more mindful of where these numbers are going to go. Okay, this is pi over 2. I'm going to put it on top. This is pi. This is 3 pi over 2. And this is 2 pi. And I'll show you why I did it that way. Oh, I still have that animation. There's cosine. Okay, same thing. But it's doing the x direction instead of the y direction. That's the purple line. And so cosine starts at 1 and then goes down. Same numbers. So cosine is going to start at 1. Come down to pi over 2, down at pi, and back up again. I'm making these 5 points. And you might have noticed I made those 5 points before as well. Right? It's those same 5 points, but we don't do a V shape, we do a curve. Because it's about the circle, and the circle's curvy. And it'll be over here too. You see why I said the very first one was a cosine function? Because it starts at 1 and comes down. And I'm going to write that underneath it just like I did with the last one. cosine starts at 1 and goes down. Now, here's the real secret. And I'm going to probably tell you this next week too. If I just were to pick this graph up, pick it up, shift it to the side a little bit and put it back down again, it's a sine graph, right? If I were to take it, pick it up right here, pick it up, move it, put it back down again, that will be a sine graph. So sine and cosine really aren't that different. They're just shifted by pi over 2. It's the same. Totally the same. Okay, let's break down the parts again. Midline hasn't changed. Still there. Amplitude hasn't changed. Ooh, that's not how I spell amplitude. Hasn't changed. Period length. This one I can go mountaintop to mountaintop. Still 2 pi. Okay. And then there's only one thing that's about to change about the equation. Instead of sine, I'm going to write cosine. That's the only difference. So there's only 2 things that are different between sine and cosine. Sine starts at 0 and goes up, and it has a sine in the equation. Cosine starts at 1 and comes down. Has a cosine in the equation. Otherwise, literally the same thing. I'm going to shift over. Hopefully that's not going to take over too much. There we go. And tell you about the equation. Okay. I have purple in my hand, so I might as well do this now. Same exact math problem. 2 pi over b. I guess I should draw the same dots. Literally the same. Only thing that changed was cosine. This is why I was torn today, because one option I could do was just to teach you sine, all the things about sine, and then next week just do it again with cosine. Or I could teach you parts of each, and then next week do parts of each with the graphs. So I decided to do this because they're so similar that next week would just feel like it's crazy. Also, hey, by the way, we're going to finish off 9.4. This is crazy to say. We're going to finish off 9.4. I'm going to give you a review. I'm going to give you a quiz, and I think that's the end of the school year. Pretty sure. I need to check my calendar, but I think I checked it this morning and it said that. Isn't that crazy? No, it's because we're a couple days ahead. Okay. Whew. So I need to check to see if I want it. I can break down graphing even shorter, or even more. I'll do that. Let's do that. You don't know what I'm talking about. It's fine. Okay. I know that somebody's going to ask me, or going to say they're confused, because this was very whole picture. And I know that somebody's going to ask me what I'm asking about on the homework. But just for those of you who are done, I'm going to show you the homework. I'll send this to you, Lauren, and whoever else is my second person. Because those ones over there, I just want you to tell me what the amplitude and period are. For this one, it's like matching, which one has an amplitude of 4 and a period of 2. And then the bottom one is we want to write a function so that way the graph has a given amplitude and period. Which is, I'm going to do one example like the very bottom one, because I think that's the only one that's going to trip you up after this stage. So, and it specifically says to do sine. So I want to write y equals a sine bx with amplitude not 1, 2, 10, or a half. Let's do 5. And period not 5, 4, 2 pi, or 3 pi. I don't know. 8. Sure, 8. 8 pi is more frequent because we really do care more about it being in pi land instead of in normal number land, non-pi land. But we're going to do this one. So the only math I have to do, because it tells me my a value, and then I only have to do a little bit of math in purple. I'm going to do 2 pi over b equals 8. If I multiply by b and divide by 8, I get 2 pi over 8 equals b. I just switched them. I switched the bottom with the other number. It's legal. And then I clean this up. 2 pi over 8 is like a pi over 4, because 2 8s simplify to pi over 4. So then my equation is y equals 5 sine of pi over 4 x. We did it! Sorry, I stopped streaming too quickly. So all I did was I cleaned this problem up and then I rewrote it over here. And that was the end. And then I'm going to put your homework up because I have to keep this under like 30 minutes and then 30 for you to work on your homework. So it's a little bit long, and I'm so sorry. It's because of all my blabbing in the beginning. So homework's up. I can email this to you, Lauren, and whoever else is watching if you want the homework ahead of time. You can also probably screenshot this, and it's going to be posted in a little bit anyways. It's just not on the Google Classroom yet. And then I think that's it. So I'll be around in the chat if you have any more questions, but I think I have to call this a day. All right.